I thought I'd do a short video on using life cycle assessments. Again, it's part of paper 2 resources topic, and it's an area that people find either yawn-inducing or quite difficult, or certainly worrying, because it's not something that's really very sort of chemistry heavy. But actually this is an opportunity for easy marks. There's been very few questions on this over the years, but there has been one or two that sort of point towards it, and one in particular that I'll look at from June 2020. Now, a life cycle assessment is an attempt to assess the overall environmental impact of a product through the course of its life. Okay, it's an attempt really to quantify that. In other words, put some numbers associated with it so you can compare different ways of making a product. Now, in the specification it says that you should be able to create your own life cycle assessments, for example, for comparing paper bags and plastic bags. There are other videos on this from people going into it in a lot more detail, so go ahead and watch those as well. But just as a few thoughts to kind of keep this simple as possible. So if I'm thinking about a question that I've maybe set for a class, I would think about, this is the little acronym that I use, DRUM-T. So I'd look at the information given and I'd go through DRUM-T. Now these are not in order, but DRUM is disposal. Obviously that's the last stage in the process. To disposal, think about the environmental impact and energy use of all of these processes through the life cycle of a product. Think about the raw materials. What's it made from? Are they finite? Are they renewable? Does it require a huge amount of energy to extract those from their ores? You know, does it require electrolysis, for example? Do you have to heat them? Does mining the raw materials cause damage to the surrounding areas? Think about the use of the product. So is it something which is you're going to use many times or use just once? Is it something that works really well or is less good as a product? Is it something which, for example, with comparing electric with petrol cars, that are going to produce greenhouse gases when you burn the fuel in the petrol cars, whereas electric cars, you're not burning fuel. You have to use electricity which has been produced possibly from burning fossil fuels, but you're comparing the use of the environmental impact of using the product. Consider the manufacturing of the product. So again, what type of energy or what type of environmental impact does the manufacturing have? And also think about the transport. So have the products come from a long way away? Are they very heavy? Transporting heavy things is hugely disadvantageous. No, it requires a lot more energy to carry around heavy things than light things, obviously. If you think about those things when looking at a set of information given to you, you'll be in a pretty good place to come up with a fairly strong answer, I would say, on the whole. Now, to illustrate this, rather than do ones you may have done in class, I'm going to use an exam question from 2020, where, as usual with these questions, you're given just about all the information you could possibly need. So you're comparing food plates made either from paper, polymer or ceramics. And by the way, and I'll do a video on different materials, but ceramics, there's a question on this, but the ceramics are made from taking clay, moulding it and then heating it up in a kiln, and you get a ceramic. And you all know what ceramics are, things like what your plates are at home. Right, so as I said before, a life cycle assessment is an attempt to quantify the issues that I've just raised on the bit of paper here, these things. And so this question here is around, well, first of all, you're given a load of stuff about the raw material, how many you get in a box, how many times you might use a particular material or product, whether they're biodegradable, so that's linking to the disposal, as is whether they're recyclable or not. But it's no information in here about energy usage, and it wants you to talk about what two bits of information would be useful here to help you make a better life cycle assessment. So essentially this is the idea of quantifying these life cycle assessments. So it's the energy used in, I'll just show you an art scheme rather than walk you through it, but it's the energy used in extraction of the raw materials, so something I mentioned before, or processing of the raw materials. The energy used in any of those things I've just talked about, so manufacturing, transportation, disposal. It's got some stuff on cleaning there as well, but any two of those would have done the job. So it's this idea of trying to put numbers with this with the information given in that table. In the second part of this, and I'm not going to use the mark scheme here specifically, I'll go through the process that I described. It asks you to evaluate the use of these materials. So you've got wood, just to remind you, you've got wood used to make paper, crude oil used to make polymers, and ceramics used to make clay. So let's go through making our own, so evaluate the uses of these materials making food plates. Let's go through that on paper here. I'll try and put a table here. I'm going to do this. Just go through it. I'll do it verbally. Right. So the raw materials to start with. So considering the raw materials, of course, you know that wood is recyclable. So recyclable. What am I talking about? What's the word? Renewable. You can grow more trees, right? So it's renewable. Also, when you grow trees, of course, they take in carbon dioxide from the atmosphere, which is an advantage as well. Whereas crude oil, of course, as clay is not renewable, so they're finite. There's a whole sort of lesson on finite and renewable, which I'm not going to make a video on. It's quite straightforward. The idea that will run out, won't run out, because you can just grow more in one's lifetime. So that's the raw materials. I would probably think about the processing of those raw materials as well, although it's not particularly in the mark scheme. So to process the raw materials, you've got to, for wood, you might want to talk about the fact you're cutting down trees, which is obviously potentially bad news, because those trees were taking carbon dioxide from the atmosphere and have a store of carbon essentially. You might talk about the fact that the crude oil might have to be cracked before being used, which requires energy and so on. But anyway, the key thing is you understand that it's renewable and finite. The next thing, so drum T, we've done the raw materials bit. So the next thing would be the manufacturing, if you put them in order. The manufacturing of them, it talks about the number in the cardboard box in the information, so you must comment on that. So you can get loads of paper plates in a pack, and you can't get many plates in a pack. So clearly the packaging there is going to be important. You're going to get much less packaging required for paper plates than you are ceramics, for example. Okay, and you might want to add bits of knowledge that you might have around clay needing to be heated. You might want to add some information about the fact that crude oil has to be cracked to make it into alkenes, which are made into polymers. You might want to talk about the fact that turning wood into paper is quite an involved process. It obviously means cutting down the trees, pulping the wood, bleaching the paper that you eventually get produced from it, all sorts of things, all of which require chemicals or energy. You can comment on those, but don't get carried away. You don't need loads and loads of in-depth information. So that's the kind of manufacturing bit. Manufacturing, excuse my writing there. And then the use is the next thing. So we've done raw materials, we've done use, just ticking them off as I go. Then manufacturing, oh no, sorry. We've done manufacturing, now use. So the number of times you'd use them. Of course you'd use the paper plate once, it'd be dirty. You have to throw it away or get rid of it or just recycle it. Whereas polymer plates might last a bit longer, and ceramic plates, well, you can use them endlessly. So 1,000 is a silly number there. You could use plates many, many times until probably they break. Okay, so I wouldn't just talk about the number of times they use, though, although I definitely would comment on the number of times they could use through the course of their lifetime. I would also say that it's much better, much nicer eating off a ceramic plate, I would argue, than a paper plate. So paper plates bend, they rip, they're not very pleasant to eat off. You can't eat them off your lap or something like that, could you? Because they bend and they're not as good. So talk about the use of them. So we've done raw materials or manufacturing, use, and then disposal. So disposal, clearly the big thing here, there's a disposal, D for disposal, is that paper is biodegradable. That's a really big one, that's an important one. They can rot down, stick them in landfill, they will rot down eventually, and that's a good thing. But they could also be recycled as well, so that's a really positive tick for paper, using paper plates. Polymers can be recycled, which is a positive thing, so I'd comment on that. And I'd comment on the fact that polymers don't break down very easily. And ceramics, of course, don't break down and are not recyclable, but you're going to use them many, many times. So you're comparing and contrasting them all. It doesn't say it specifically in the mark scheme, it kind of comes under transportation, but I think so it comes under manufacturing, but the transportation thing, so drum T, it's worth considering that ceramics are much, much heavier than paper plates. If you're transporting, say, a box containing 10 decimeters cubed of them, that's going to be much heavier for ceramics. It's going to take a lot more energy to transport them around the world, let's say. So comment on the transport as well. And it does say in the mark scheme, paper plates need less transportation overall because you've got more in a box. Right, so the last thing you need to do though, and if I just show you the mark scheme now, we've covered all the kind of indicative points there. Easy, 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 easy. Just comment something on each of those things, drum T. And then finally, it does say reasoned judgment. So you're not going to get a level 2 answer worth 3 or 4 marks unless you give some sort of reasoned judgment. It doesn't really matter what your judgment is. This is better than this because this. This is worse than this because this. So I think ceramic plates are the best because you can use them many, many times over a leather. So just give you, it doesn't really matter what it is, but you support it by a sufficient range, whatever that means, of arguments. That's it.